Okay, so we're going to review converting decimal numbers to binary. We're just going to review how we do it in our heads and with paper, and then we're going to go ahead and write some code to do it. So right now we're going to take on the problem, convert 211 to binary. So remember, the first question we ask is, does 128 go into 211? Well, in this case, the answer is yes. Okay, that's the answer. So when the answer is yes, the output digit is 1. And we have to do a little subtraction. 211 minus 128 equals 83. Now we ask, does 64 go into not 211 now, but our new number of 83? Okay, and the answer is yes. So the output digit is going to be 1. So now we're going to say 83 minus 64. And that equals 19. Okay? So this is what's known as an iterative process. So now we're going to say, does 32 go into 19? The answer is no. Do nothing. Okay? This binary digit is 0. So the output is 0. Does 16 go into 19? Yes. Subtract 16 and output 1. Okay, so we're going to go ahead and subtract 16. We're going to say 19 minus 16. Oops. 19 minus 16 equals 3. We output a 1. And we continue to do this. The next thing will be 8, and then 4, and then 2, and then 1. Okay? So our test values are going to go from 128 to 64 to 32 to 16, and so forth. Okay? And that's how we do it without a computer to help us. So now we're going to create something. We're going to create something called a digit value. And we're going to start that off at 128. Remember? Because that's what we did. We started off subtracting, looking at 128, looking at 64, 32, and so forth, right? So we have this sequence. Let's create a counter variable. And we're going to do this process iteratively. I'm going to do it and then amend it because I just want to make sure every part of it is clear. Okay, so here's our counter. Remember we said we were going to do 8-bit values. Now here I'm going to printf the digit value is %d. We just want to keep track of that digit value. Okay, let's go ahead and run this guy. Now you'll see that the digit values were all 128, which is perplexing because we really wanted 128, 64, 32, and so forth. But the reason that we saw the incorrect values is what we were supposed to do was divide here. Digit value divided by equal 2, right? So we divide by 2, and that way we'll get 128, 64, 32, 16, and so forth. Sorry about this, I have to bring over the command prompt to the side every time. I've got 2 monitors, so that's why this happens. Okay, so 128, 64, 32, and those are the bit values that we're going to be considering. And that's all well and good. Now what we want to do is we want to ask the user for a value, a decimal value. And we'll ask the user, that way we don't have to go ahead and put something in ourselves. So I'm just going to do a little bit of copy and paste. So here we ask the user what value they want to convert. And we give them a little reminder here that we're only looking for values from 0 to 255. Okay? Okay, if the digit value, in this case we're going to start off at 128, right, is less than or equal to the decimal value, okay, so here's we're doing the same test that we did back here, right? We're asking the same question, okay, If that goes into 211, it's less than. If that goes into 83, it's less than. If that goes into 19, it's less than, but it's not. So that's the test that we're doing. Okay, so we subtract decimal value minus equals digit value, right? And then we're going to output a 1. Okay. Otherwise, we're just going to output a 0. Okay. So here's the test. If the test passes, we subtract and we output a 1. All right, so let's go ahead and run this thing now. And let's do the same, let's input the same value that we did before, 211. And so it outputs on the left 1 1 0 1 0 0 1 1, okay? Which is correct. Now, just to let you know, this doesn't look very nice. So what I want to do is just output a decimal value. I'm going to comment this out. And if we comment it out, that way we can always get it back later. And here, instead of this \n, I'm going to make this a blank space so it'll look a little bit nicer. Finally, I'm going to do a printf here, \n, so it just looks really pretty. Yeah, let's go and run this with 211 again. Gives us a nice binary number. Let's do it with something smaller now. Let's say 33. Okay. So there is our converter. Now we could actually do this with a while loop. That's with a for loop. We can actually do it with a while loop. So I'm going to go ahead and comment all this out and make sure that it's there in case I want to refer back to it. Okay. So we can do this with a while loop. So I'm going to say while digit value is greater than 0. The reason I'm going to do that is because we're going to continue to do it while it's 0. Well, excuse me, while it's greater than 0. First it's going to be 128, then it's going to be 64, then it's going to be 32, then it's going to be 16, and so forth. And I'm going to grab this stuff here, and look, just like we did with a for loop, what we want to do is we want to test this stuff piece at a time and just make sure it all works, okay? So this all should work. Let's just make sure it works. Do 211 again. $128, 64. So the bit values are doing exactly what they're supposed to do. Okay, at that point, I'm going to get rid of this, comment this out, just because it's kind of in the way. We just did that to verify. So now we're going to do the exact same stuff here. We're going to do the test. And here I can just do a copy and paste. It's the same exact test. I've just organized it a bit differently using a while loop. Okay. Well, this should actually work. 211. Exactly. Oh, I need that end printf, which I had commented out, so it looks much prettier. Let's run this again with a smaller number this time. We'll say 34. Okay, excellent. So hopefully this video has helped you understand those converting algorithms.